Okay. All right. Hello, everyone. Good afternoon. So for today's class, for I think around 30 to 40 minutes, I would like to start a new section, which is the antiderivative. Okay. And then the second half of the course, we may have some exercise. Okay. To prepare your midterm. So the antiderivative, okay. You mean this one? The midterm?
No. The slides are not yet.
Which one?
This slide.
No, not yet. Not yet. Not yet. Okay, so antiderivative, as you probably try to digest, we learn derivative, right? Now this is anti. Okay? So basically, if you are familiar with the integrations, this is what we call the integration. But this is what we call the so usually we write like this, right? But this can be definite, can be indefinite. For the antiderivative, in general, this is we call also the indefinite integral. Okay. Indefinite integral means that we are not going to calculate in the exact number, but we will learn very soon what this can mean. But for now, let's just stick on the antiderivative. Okay. So suppose that you have the y equal let's say x squared. Okay. We can derive it easily to x, 2, and then 0. But we need to think what will be this function before it was derived. So let's say if this is the result of the, what will be the y? Or maybe to make it more clear, let's start with if this is the y prime, we would like to know y. So you need to think, maybe before this it's cube, but if you derive the cube, it has 3, then it would go front, 3x squared, right? So you need to define like 3 to make it x squared. So do you agree if I write this will be 1 over 3 x cubed? Okay, it makes sense, right? It makes sense because if you derive, it's cancel this one, and then we have 3 minus 1 is become this 2 x squared. Okay. Now basically that's the simplest way to understand what is antiderivative. Okay. So we can make some theorem on this one, and then we need to add with the constant. Okay. Because constant, if we derive it to 0, so we're not sure yet whether we have a constant or not, but we need to write a constant, okay, to make sure that if we derive, we are fully have all the components ready. So as in definition, if the capital F, and this will be, I think, the standard for writing the antiderivative. Usually write with a capital F. Okay. So we say that this is an antiderivative of the small f, okay, on some interval. And then the general antiderivative is basically this capital F plus constant. Okay, the one what we add here. Okay. For the c is an arbitrary constant. When you derive this, the c will be gone. Okay, when you derive this. Okay. We could also define, maybe for the beginning, before that, we can also define the f is antiderivative of f if the capital F prime x is equal to f of x. Okay. The whole definition here will be very essential, especially when we are going to dig more into the integration area, especially to connect derivative and integral. There will be some connections later on that we are going to learn very soon. Okay, now suppose that we have this x squared, as I mentioned before. If we think like how many possibility for the antiderivative, basically we are going to have 1/3x cubed plus constant, and constant can be any number, right? Basically we say that we can have a family of the solution or family of the antiderivative like this. So this is the antiderivative, or we can write that since the f, we can write as this. So according to C, we can basically have this possibility, okay? From the same concept, from the same logics, we can also try to make out, for example, if we have f okay, so if we have sine, what would be the antiderivative? So the logical way to see this is what kind of functions that when we derive, it was resulting sine, cosine, right? Cosine. So cosine, if we try to make out, it will be, we can check, right? We can check. So try cosine. If we derive this, it will be negative sine. So I think we add negative to make it positive, right? So the sine become negative cosine x plus c, okay? If we have 1/x, for example, we need to think what kind of function that when we derive it's 1/x. Yeah, ln, right? But we need to make sure to write the ln with absolute value. I think I have given the reasons why, right? Okay. Don't forget it's absolute value, because both the interval, positive interval and negative interval, they are going to have the same derivative, which is 1/x. Okay. Or plus c, forget plus c. And then from this x squared here, it seems that we can also write in general patterns that if we have the x with power of n, okay, then to make this happen, then we need to at least +1 for the degree, right? So we can write, in general, we can write this could be xn plus 1, and then because of it will going down, so we need to cancel out, right? So we need to add this n plus 1 at the bottom equations. Yeah. So, and this is, we can write valid for n at least 0 or positive. And this logic, sometimes, okay, when we deal like complicated integrations, sometimes if you can arrange the structure of your integrations, this logic sometimes helpful. Like you can think like what kind of functions that when you derive, it becoming that one. And then you can try, we call this method like a guessing method. It's not on your textbook, but it is, I think if you watch some tutorials from MIT, they mention this techniques. It's called the advanced guessing method. There are particular like questions that can be, we can guess what kind of antiderivative of a typical function. Maybe later if we have time, I can get into that method. But basically the method is guessing. Okay? So you take some functions, you try to check when you derive, can it be this one or not? Okay? So you guess. Okay? I think the other one, like e, I think it's easy, right? E to the x is same e to the x. And then what else? The other one. Basically all the standard form in derivative, like all the standard formula, you can, so yeah, you can reverse that. Okay, you can swap that. Like if you have maybe not e, maybe b, just a normal base. So basically the antiderivative will be p of x and then ln b. Okay, this ln b is because if we derive this, it will result ln b, so we need to cancel that out to make it this one. Okay. And like tangent and others as well. I hope you're still okay with that. Like this, like, you know the derivative of the sine inverse, tangent inverse, right? Similarly, you can swap that out also. Okay, so that's the some formulations. What else? Yeah, pretty much that is the antiderivative, the introductions. So the next part is the yes. Oh yeah. I forgot to write. Let's see. Okay, good. Thank you. Okay, now from this part, which is the antiderivative, we need to make sure and know what is the application. I mean, what is the intuitive real application for this one? So we can think the like the area of this curve, okay, under the curve. Let's say we have the s, okay? We have the x squared. So basically, the antiderivative, when we deal with antiderivative for this curve, is actually represent the area under the curve itself. So, but before we are getting into that definitions, let's start to try to see how we can probably calculate the area. The curve itself, it makes our calculation complex, right? Because we don't know, like, it's not a normal geometric shape, right? So the way we try to find the area is try to split or maybe cut into several parts. And we need to make some approximation. So suppose that we are going to cut this and make a rectangle. Let's say we can make, let's say 1, 2. Let's say we take this much, okay, and then let's say we make all this rectangle. So we have 4 rectangles. But somehow if we know this part, if we know the distance, and then we know this distance, and of course we know the distance from the function. Right? If we know this x, that is the height, which is this one. So we can multiply height and base, and then we can plus all of them. And we kind of having the area of these 4 rectangles. But there is a problem because we have overestimation, right? We have overestimation. So in terms of the what is this red color? This is what you call the error. Okay? So you have the value that you want to know, and you have your method to approximate, okay? Which resulting overestimation, right? So this is we call the overestimation or the error. Sometimes it can be over, it can be underestimate. Okay? So how to make sure that our error can be as minimum as possible? How to minimize this error? We need to make sure that the error is as small as possible, right? One way to make this like really, really small, we cut more. Can you imagine? We cut more. Maybe this is like 1, 2, 3, 4, 4n. Okay, let's so n is 4. If we can make n maybe 20, 50, even 100. Can you just visualize? Take that and then all. So you see that the estimation is really, really small. Okay. Basically, that is the definition of the integrals. Right? So let me review what I'm saying. Okay, so here we cut into 4 area, and we try to approximate. We try to approach this area by taking this rectangle, okay? And then all this distance we know, and we can also know the height, okay, from the function. Okay, this is x squared, so which means that x equal 1. This is 1, so this 1, and this will be 1/4. 1/4, and this is will be, we put 3/4 inside the x squared. And we know all the numbers. Let me put some numbers here to give you some context. So the area here, so this will be 1/4 and 1/4 squared. So let's say this is the 1, 2, 3, 4. And then this is plus 1/4. 1/4 is the x, okay, the distance x, the delta x. And then this will be half. And this will be 1/4, and this will be 3/4, and this will be 1/4, and then 1 squared. This is 1, 2, 3, 4, 4 rectangles. You can try to count, and the area is around 15/32, or around 0.468. From the figure, this number is too much, right? So the A should be less than this, right? But we can have another approach, okay, using similar rectangles. We can make it into this one. So we can make it into this one, and we can have, it's actually 4 rectangles, but the one rectangle is 0. So we can have below, now it's below. Okay? This is underestimate. The same way, we could take this rectangles and then put into the our formulations. Let me write this as the not A to make clear this is A or R. R with 4 rectangles. R means this is based on the endpoints on the right. This is endpoints on the left. That's touching the curve. Okay. This means right endpoint. So we do the same thing with this, but with the left endpoint. So the first one, the height is 0. So let me just write 0, just to make sure that we have all the similarity. And then 1/4. This is 1/4. 1/4 squared. Now it's the left one. And then plus 1/4 half. And then the last one is the 3/4 squared. Okay. Because now the one that is touching the curve is the left part. Okay. We can compute this, and this will be around 7/32 or 0.218. Now, based on our observations, the area, before we say that it's less 0.468, but the area is more than 0.218. Okay, so you see that this is underestimate, that is the overestimate. So the real value is between, and it's between this number. Okay, and you can let me write. Oh, I don't have now. You can increase the n. So for example, you can try n equal 10 and equal 20 and so on. Maybe you can even try n equal 100 if you want. Okay. And then you can see the L and R. Eventually, if you try like increasing the n, you can try to use some simulation. But if you try this way, you increase the n, the L and R, they are getting close together. Okay, so this one is getting higher, the right one is getting closer to the left. So somehow we can see that when you get the 100, for example, this will be around this, and this will be around this. So it's getting closer together. So at the end of the day, it will reach out around 0.33 something. Okay. This is to show you how we can approximate using our geometric structure, or this is what we call the Riemann method, or the Riemann sum. Any question? Yeah, there are several methods. Any question?
Actually, I have a question. Would you get the numbers for like?
Oh, what is that 1/2?
Like what is 1/2 and what is 4?
This is just an explanation, so like what's the standard? Like,
But you need to understand.
no, I do understand
Yeah.
that. Like, when you put these kind of like for us to explain this way in next time.
Not sure.
I won't give you that.
A little 4 did.
You mean this one?
Yeah.
Yeah. Okay, so let me put this two graphic. So the first one is based on the right side, that is on the curve. This one based on the left. Okay. So we know the distance, all the distance is 1/4. Okay, 1/4, right? The touching with the curve is the point on the right, this one, right? So we have 1/4. 1 over 2, 3 over 4, and 1. This part is actually from 0, because this is actually, you can think this is a rectangle, but it's not having any distance, 0 height. So 1 over 4 and 0, and then 1 over 4 and 1 over 4, 1 over 4 and 1 over 2, 1 over 4 and 3 over 4. Okay. Okay, now just to make clear, so this is what we call at the end of the day the Riemann method, or the introduction to Riemann method. I will show you later what is the Riemann method in clear and complete. So basically, so this is your calculus, okay? Calculus 1. So you have derivative with all components in derivative, and you have integrals. In integrals, first we learn about actually the intuitive definition. This is what we have at the beginning of the class as the antiderivative. Okay. The second part of the integrals is what we call geometric definition. In which this is going to be explained by the Riemann sum. We call also, this is called the indefinite integral, this one indefinite integral. This one is definite integral. Okay, just to make clear that this is what we can elaborate from the integrals. Okay, now continue to the explanation for this rectangular shape that we did on this two examples, right endpoint and left endpoint. And if we try to look at more clear, if we increase the n, you will see that slowly the error is minimized, right? The error is minimized. So this is, so error for both sides is getting, or just maybe minimized. Okay. Now if we increase more, or this is example on if we increase how many n you can see, and then the impact to the left endpoint and right endpoint is getting closer together. These two values getting closer together. Okay, and then let's say we have this. Okay, in general, okay, if we have this. So suppose that we have S1 until Sn. So imagine that we are going to cut this with number really high in n, or you could say n is getting higher and higher, or getting infinite in general. Okay. So the interval, okay. So the width, okay. So width of interval AB is b minus a, right? So every delta x, so let's say this is the delta x here, maybe here. Okay. let's say that is delta x. So we can also approach this delta x. We can approach delta x as the interval, which is b minus a, the distance or the width, divided by how many slice, how many cut, divided by n. Okay. So if we look on the slices, then we can start. So if we start from a, and then let's take x1, it's becoming a plus delta x. Okay. And then x2, we can say a plus 2 delta x, x3, a plus 3 delta x, and so on and so forth. Okay. Or in general, we can have x with some I, with some numbers, that is a plus that numbers delta x. Okay. And then we can approximate. Okay, we can approximate the strip for each rectangle. So let's say we're going to use this xi, and then using the f of x for each I, okay, we can approximate that. Suppose that we are going to make it as a right endpoint. Okay. So I can write here. Let me write. Okay, that is the approximation. So we are going to take this on the right endpoint. So we are going to use this x1. So the height will be f x1. This is f x2, and so on and so forth. So now, by taking the same approach with the previous previously introduced the right endpoint, so we can write this f x1 delta x plus f x2 delta x plus all until some xn, and then still delta x. So we can factorize the delta, right? Or maybe let me just write this first. I will explain later. So we expect that n is, so expect that n will going higher and higher and larger and larger. So when the area or when the n is getting larger, then we can also expect that this is going to be a limit problem. Okay. So the area is basically a limit as n approaching infinity of the Rn. Or we can write the whole thing with the f x1 delta x plus f x2 delta x up until the xn. Or I prepare on the bottom side here. Wait. This will be, let me exchange this first. Okay. This is more clear. Not yet, no. We go there. This is like introduction to that. Not yet. Okay, but this definition is only for the R, which means these right endpoints here. Because we can also have a left endpoint. But to make some theory for all possibility, we need to make that this endpoint or the right endpoint, left endpoint, we should make it more general. So we need to take what we call a sample point. The sample point, basically, we can just make up the rectangle, and then we can set up the rectangle crossing not on the right side or left side, maybe in between right and left. Okay. We call it a sample point. But the shape of the rectangle all should be similar delta x. Okay. Let me show you what I mean by that. Okay. Okay, this is what I mean by the sample points. So you have the same delta x for each rectangle, but the way we put the rectangle, it can be in any points for each curve. Okay? It can be here, 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 and we call this with xi with this some star. We call this a sample point. So it could be applied everywhere. Okay? So it's more general. It's not restricted only for right or left endpoints. It can be anywhere. It can be anywhere. So we call this a sample point. So this xi is a sample point. So with the same logic and structure, we can write a limit of this f. Let's just write 1 and then asterisk. And then delta, and then plus, and then asterisk, delta, up until xn. Okay. So basically, these additions will get into this what we call the summation, or using the sigma notation. So let me write here, maybe here. So sigma from I equal 1 of this fxi delta x. This is basically stated that the whole thing inside here, which is fx1 delta x plus fx2 delta x up until fxn delta x. So the equations, or maybe let me write on the bottom side to make it more space. Okay, now based on the summations here, we can write our a as limit and then this will be f xi and then delta x. Are you familiar with the sigma notation? No? So it means that we start from I equal 1, okay, up until n. N is the endpoint of your plus, 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 plus. So we are expecting to plus all the this particle I. So, for example, start from 1, so 1 here, x1 plus x2 plus x3 and so on and so forth until the n. Usually, if you are learning like from the very beginning, the summations usually start with the number. So maybe 1 to 20. It means we add for this formula 1 up until 20. So we have a 20 components inside. But now, since we are dealing with something really large that is close to infinity, or we are getting closer to the infinity, it means that we are expecting that there will be a lot of components. So that's why the summations become really important in our formulation. Okay. And there are some formulations that we need to know beforehand, but I cannot really explain for a while. But I will just write first, okay? So note that we have this is equal n plus 1 to n plus 1 over 6. Okay. Okay, remember in this case, this is we know beforehand, okay, that we have the sum for the formulation of the I squared will be equal to this. Usually you will get this on the sequence series, okay, sequence and series, okay. But if don't have time to explain this, I will just give you more information later on, okay? So so first is this, or maybe let me write completely. Okay, let me write completely. So we start from I. I think this is most of you know, right? This one. This is from the series. So you have A1 plus A2 plus A3 blah 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 blah. Or you could imagine like 1 to 100. What is the additional terms of that? It's basically this this solution here, the formulation. And we can also increase to I cube, which equal to n plus 1 over 2, and then squared. Okay. This is just additional notes. Okay. Okay, let me write down here as a conclusion and what is the integrations actually. So if f is a function defined for the interval AB, and then we divide the interval AB into sub-interval of equal with delta x equal b minus a over n. And then we let the x0 equal a, and then x1, x2, until the xn, the last one will be the b. Okay. And then we let the x1, x2, x3 until the xn with this star or asterisk. This is a sample point. let me just finish off the writing first. Okay, just a few words left. Okay, and then the xi, it lies on subinterval of the xi minus 1 xi. It means that it can be in any rectangles. Then definite integral of f from a to b is okay. Okay, we can have a break first. Okay, so I hope everyone try number 2. This type of question is not like you can like make it like really fast, really quick. No, it takes some time, really slow. First, you can analyze first, identify first. Okay. Tangent inverse xy. Okay, we have that, and then ln x plus y, and then x with power of y. First thing first is you can set apart. Okay, maybe you can find the x with power of y first. You derive, you get something. Okay, that will be this one. Okay, you derive this, you get something. Okay, if you feel like writing in the long run like this, maybe will make you house more. So you can separate and then make your life easier. Okay. So first is you need to deduce. You need to make deduction, like a deductive. So actually, like mathematics or calculus, if you know the question, if you understand the question, if you can analyze and identify what is the question means, what this means, and what is your goal in this question, then the next step will be very, very clear and obvious which way you are going to go. And sometimes there will be some choices that you need to make, like what kind of techniques you would like to use, right? And it's up to you which one the method, as long as it is consistent, logical, and you can have proven it. Okay? That it's okay. This is true because of this. Okay. So it's like you are being like a detective. You are trying to solve a case. You need to have what is the evidence, who is the culprit, for example, and you need to find all those in the question. If you are for some reason cannot understand even the goal of the question, it means like you can ask yourself like how many percent that you know and how many percent that from that you know you can solve. Hope this makes clear. Okay. So basically, the idea for the finding tangent line, normal line is finding what? dy over dx, which is the first derivative. But how we can make finding the first derivative from the equation that involving y inside? Well, you could argue that, oh, we can make equation y equals something and then we integrate this x. Well, for this case, it seems that it's not applicable. It's not like it's I think almost impossible to make this equation explicitly in y. So the only way that we can do is we take the implicit differentiation. Okay. So I hope everyone remember how to do it. Okay. If you are still confused like what is implicit, or we miss like the whole section on that, or the whole chapter. Okay. So this one, okay. You can start by, if you forget like one by one, you can start like, what is tangent inverse? Maybe in x first, okay? Do not include this y. start taking the, what is the ddx? Tangent inverse x. Oh, this is 1 over 1 plus x squared. Okay? So every time we have anything inside here, can be xy, can be x cubed, can be x cubed y, can be y squared, or anything, we can make this structure, right? And then don't forget, we have chain rules. Okay? So implicit chain rule, and it's always combined like that. So it's always involved the chain rule. So this one, let me erase this. So this one, it will be 1 over at least 1 plus xy squared, and then I will write one by one, d dx of the xy. Okay? And what is the xy? So you could treat this x and y as two different functions, which you can conclude that, okay, we can make a product rule, right? We can make a product rule. And remember, in the implicit differentiation, for y, you need to write in terms of dy over dx, okay? Because we treat y as a function of x. And because of the chain rule, we need to write the derivative of y will be dy dx. So let's write the product rule. So this will be y plus x dy dx. And then the whole thing will be that. Okay. Just write as it is. Do not even try to multiply. Okay? Do not even try. You will make your life difficult. Okay? Just write first. Write first. And then the same thing with the ln. Ln, you have a function inside. This will turn out to be, if you derive 1 over something inside. Inside can be anything. So you can first write. And then multiply what? The chain rule. Okay? Similar with that. So this will be 1 over x plus y. And then we derive x plus y inside. 1 plus dy dx. Okay? So we got this, plus we got this, and the rest is this one. Okay? If you feel in one line, you feel exhausted, you feel like confused to your maybe to your brain, separate it. So this one and this one, and then you can let maybe another one over in another functions. You can always try make a new functions. Okay, so you can let maybe g. Okay, let's make g is x with power of y. Make up a new functions. Okay, you can always try to do that. Okay, so let's make this and try to solve this and try to take the first derivative of this. The idea, every function, if it is have another power, another function, we need to make this power comes down, right? Because it's function and function. So we need to make this down. Take the log, right? Take the log. Take the log. And we can make this going there, right? So we can write ln g, y, ln x. And then what? This, another product rule like this. Okay? Y and ln x. Two functions, okay? So we can take the first derivative. So ln g becomes 1 over g, and then you can write g prime, or let's just write g prime. But every time you write something new, you need to know the definition, okay? Just because I know like some students, you write something, they don't know what it is. So at least you need to know like your consistency. For example, in the questions related to related rates, sometimes the question doesn't really give you the variable. You need to make up by yourself. You need to know which variable you set. Okay. Okay. Do not mix up. Okay, now this equal to y ln x is y over x plus dy dx ln x. So let me write. Maybe let me write in a new page. Okay. I think I don't have space. Let me write here. Okay. So let me write the question. Or maybe the last one. The last one is this. Or maybe let me solve this first. Okay. So g prime is g is x with power of y. Multiply with this. Okay. So we have this, we have this, we have the left one there, that one. Okay. So put everything inside. So it's like really long and big and complicated, but still we can try to solve it like slowly, and we get 1 over 1 plus xy squared. Okay, and this one become becomes xy. Okay. The next part is the point is what? At the point 1, 0. Okay. So where is our slope? Where is our slope? What is our slope? dy dx, right? Inside here. But since this is pretty much like big and chunk, my suggestion, do not ever try to solve it in terms of dy dx. No time. So just keep this. And the next thing is, when you try to get the slope, you need to put the point, right? So let's just put the point and then solve for dy dx. Because the point itself will help you to get rid some of part of it, okay? So this is going to be at the at xy equal 1, 0, right? So we put everything inside, so 0 here, so it's just 1. 0, 1, okay? So 1, 0, this is 1. Okay, so everything you can make it simpler, right? So just plug in 1, 0, 2 inside. Okay, so you will get 1 over 1 plus this is 0. This is 0 plus dy dx. Plus 1. This is 1 and 0. This is 1. And then 1 plus dy dx. And then x with power of y is 1, right? And y over x is 0 plus ln 1 is 0. So everything on the right side is 0. So this will be 0. This will be dy dx plus dy dx. Oh, is this true? 0, 0, 1 half. Wait. Let me check. Is this true? Y, x. Okay, I think slope is 0, right? So the normal line is there. There's only horizontal, right? From here, is there anything and that I put wrong? 0, 0, 1. Yeah. Interesting. I think there is something wrong in the question, but I forgot which one. This should be 1 over 2. Let me check the question. It's 1, 0. Okay. Okay, this should be 2 dy dx is 0. Okay. Do you see any mistake in my process? 1 over 1. 1 over 1. 1. Good. So this will be plus 1. Okay, now we can solve this. Okay, even I sometimes I make mistake. This, right? Is there any process that is 0 dy dx, right? Now it's correct. So the slope is, so this is the slope, right? So normal line is 2, right? So y minus 0 multiply equal to x minus 1, or y is 2x minus 1. Okay, we got it, at least. Yeah. Which one? Oh, this one? Okay, I think we can have one question more for discussion part. Which one do you want to discuss? Number 4, I hope you can practice. Oh, there is A, B, C, D, sketching the curve basically. Arbitrary is, you can think arbitrary like any number that can be multiple ways. It's just usually we say like arbitrary constant, which means that it can be in any number for that constant. Well, in summary, you can just ignore that. Okay, which one? 1, 2, 3, 4. Number 4 is sketching the curve. So 1, 2, 3, 4. Any idea? Number 3? Okay. Okay, let's try number 3. This is the function. You have piecewise defined function. You have the interval. The function is continuous everywhere. And A is arbitrary constant, or A is a constant. Find A. Find A. The second part is question about differentiability. Is f differentiable at x equals 0? Yes or no? But please provide the proof. Okay, try that one.
Elecciones eso.
This one? This is slope.
Ini nyari original asymptotic. Jadi begitu x to the power of 3 atau x to the power of 2?
Yang paling besar.
Yang paling besar x to the power of 3. Berarti ya original asymptoticnya apa?
Kira-kira apa?
1 minus ya ini 0.
Nggak ada berarti.
Oh, nggak ada kan? Soalnya kan ini dibagi 0 jadi 0 semua kan? Terus kalau 0 berarti apa? Undefined
Nggak,
nggak?
nggak zero dong. Satu dibagi 0.
Oh ini 1 bagi 0. Ya infinite.
Iya, nggak ada berarti.
Nggak ada. Okay, thank you.
Okay, now to find the value of A, remember that f is continuous everywhere. What does that mean? Yeah, that's one, and then another one. Not exactly. But before that, the limit of that function is equal of that function itself. Okay, that means continuous. So let me write here. So continuity, okay, continuity means that limit
We talk about theory, I can pass.
it is a theory. But you need to show the theory and then apply in the question. We need to make balance.
I literally erased it first.
Okay, so you need to make this equation, which means that we need to find the limit exists first. Means we are going to look on this piecewise defined function. We have at least we have two intervals. Intervals that is negative and positive. So the best way to state the limit is x approaching to yes to zero. Okay, to zero. Okay, get it? Or still not? So limit as x going to be 0. This is equal f of 0, and this part on the limit, we need to make sure that it is the same from the right and from the left. Okay. Now from the right we have x squared ln x. So limit, this is x squared ln x equal. So we need to solve the limit first. Solve the limit. X squared and ln. I think I mentioned that whenever you have limit, you have like a composite. It has ln. You need to see the obvious that it might be L'Hopital rule. So let's, so let's put the x squared down here. So yeah. Yeah. Maybe I did some damage. Okay, let's make like this. Okay, if we put 0, this will be like infinite, right? So we can take the L'Hopital rule. Like L'Hopital rule. So this kind of question is kind of like smart question because it's like combining like most of the calculus part 1. So this will be 1 over x. This will be negative 2 over x cubed. Or let me rewrite again. Okay, let me rewrite again. And okay, let me write here. Okay. So we try to solve. Cancel this, cancel that. This will be 0. Okay. So it needs to be equal with the other side. So we take the other side limit as x approaching 0 from the left of the sine 3x plus cosine 2x plus a equals 0. Put inside 0, right? Put inside is 0, cosine 0, 1 plus a 0. Okay. To make it equal, then a is negative 1. Negative 1. Okay. Okay. Like somehow like the equation, like you see like you small equation, but the way we process is sometimes like maybe short, not really that long. And this type of question I feel like it's really like smart question rather than like write really long. So you need to be careful when you write your solutions and you feel like it's taking so long. Maybe you are in the wrong direction, okay? Okay, just be careful, okay? Be careful. So this is number A. For number B is f of x differentiable at x equals 0. To know whether a function is differentiable or not, how do we do or how do we know? How do we know about the differentiability? Yes, what? Continuous, okay. We've done continuity, right? And then what else? What else?
Something. Oh yeah, lower self.
Okay. What other things?
Let me open my.
Yeah, order, and then what else? What else? Oh, sorry. What is that? Are you finished?
Bonus points for me too.
Do you want to know this one? This last one? Okay, let me write. Okay, so to know whether the function is differentiable or not is basically take the limit definition. Okay, take the limit definition. Let me write the formula. Okay. Okay, and then we want to make it x equals 0, right? So basically, this is at a equals 0. Okay, but we can see that this can be we can see from the right and from the left.
Quando me mandar para
It's 3x or 2x? I forgot the question. Let me write question. Oh, 2x. Okay. So we solve one by one. Okay. So we solve this. Cancel. 0. Okay.
No va a ser difícil. Pero tienes que acordar los si se usa todos los
Nada, que no hay